Hey guys, welcome back to Henry's Hill Tutoring, and today a video about networking. In this one we're going to look at a new lab network that I've built here, focusing on the switching elements first, and then we'll break into some other videos in the future about routing as well as about how to use some management software such as TagHacks Plus to enable things like centralized authentication, authorization, and accounting, as well as how to integrate that with things such as Active Directory and LDAP using the Linux pluggable authentication module. We'll also have a look at doing a setup of Rancid, which is the really awesome new Cisco config differ. Now, it's a bit of a misnomer because it is no longer new, and it no longer supports only Cisco. It will work with Juniper, Brocade, Fortinet HP, and lots of other vendors out there. So, TagHacks is useful to limiting who can log in to what device and limiting what those people can do. So you can define different groups, so certain users will have certain access rights and be able to run certain commands only, whereas Rancid is basically used to manage and back up your configurations. More back them up than manage them, actually. It relies on a system called the Concurrent Versions System, or CVS, by default, to track changes between different configurations that it observes on your devices. It will run however often you want, logging into and retrieving the configuration that's currently running on your different devices in your network, and then it'll tell you if it observes a change, as well as what that change is, by way of an email notification. If it can't log into a device, it will tell you about that as well, so you can go and fix whatever's broken and make sure that your configs are being maintained and backed up by this system. So it's very useful for situations such as, say, you have a device that's failed and you must replace it with a spare. You can then take a backup of that previous device's configuration, and you can load that backup into the new device and deploy it into the network. Or if, say, someone makes a drastic change or some other kind of adjustment to a switch or like router, basically, they can back that change out by simply going and looking at the previously backed up config and restoring whatever element was there prior to their change. This is very useful if you, say, have someone that makes a big mistake and does something like no router BGP on a Cisco router and erases the entire BGP router configuration, or some other major element of the config and breaks the service. You can then restore that quickly by just copying out the necessary lines and putting them back in place. So anyways, let's get started here. We'll have a look at the network layout we have going on here. So this is a simple setup with 4 switches. We have these 2 up top here, which are part of a collapsed core, and then these 2 down here, which are our access edge switches. They've been linked up in a mesh. There is actually a link across here, but it's been turned off. Spanning tree has been augmented to ensure that traffic flows up into the core, across, and then back down to the other access switch in this case. You can adjust how this works by changing things like spanning tree link costs and such like, and maybe there's need for you to do this, or you can leave it as default, which would be to have this link as active and this one is the actual alternate path, basically. So now we've got down here a couple routers as well as one up here. This router here is linked via an access interface, and this router here is linked via a tagged trunk interface, as is this one. So we can support VLANs on these links, but we only have one VLAN defined here. Of course, between our switches, we have trunked interfaces, so we can support VLANs, and we can add and remove them as we see fit. When our testing today, we'll be using VLAN 500, and we'll have a little simple subnet. We're not going to do a whole lot. We're just going to look at configurations and just do a simple little demonstration of how spanning tree works to protect you in case of link failures. So let's get started here. These are our different switches. We'll just review the configuration on this guy first here. We'll just go over a few little commands. This is one you want to make sure you have present. Service password encryption ensures that any passwords assigned to your user accounts and to other elements of your configuration are encrypted. You should always have that enabled on all your devices. Next little command here is the host name we're defining as lab_s1. Of course, after this we have a user defined, the admin user, with a privilege of 15 to ensure that you can use this guy to manage your device. And we've turned off AAA on this one. That's just for the time being. In a separate video, I'll go through the process of activating TrackHack's authentication, authorization, and accounting on this device. It's present on the rest of these three, so that you'll see elsewhere here. But yeah, we'll go through that because that can have little pitfalls here and there if you're not ready for it. And next we're defining the IP domain name. This is something that's required if you want to have SSH on your devices. You must have a domain name defined. The next thing we have here is we've disabled VLAN trunking protocol. This you should pretty much always do, unless you know what you're doing and you use VLAN trunking protocol to manage the VLANs in your network. If you have like a lot of VLANs and you want that, then you don't use it, but otherwise turn that off because that can be very risky. If that's enabled and you didn't realize it, and you bring in a new switch one day that also has VTP turned on but has different VLANs, it's potentially possible for that switch to overwrite all the VLAN configuration on your network and thus cause a major disruption to your service and a huge headache for you to fix. So turn that off. Next we have span tree configuration. Now by default, rapid per VLAN span tree is not enabled. It would probably just be per VLAN span tree that you'll see. So if you're using a Cisco device, you'll want to turn that on because this will improve convergence times in the event of a failure. The next thing we have here is we've set a priority of 0 on VLAN 500. This just ensures that this particular switch will become the root bridge to influence how traffic will flow through our network from a layer 2 perspective, basically. So next we have some VLAN configurations. We have VLAN 20 for management and VLAN 500. This is only present here because I'm sort of doing a bit of double duty on this switch. I'm using this switch as my out-of-band management switch for the other switches and devices in my network, in my lab network that is. And you don't want to do that normally in production. If you can afford to do so, ideally, always have an out-of-band network to manage your devices. That way, if something bad happens on the in-band network, you can come in via the out-of-band network and fix it, or vice versa. So this is sort of like your ticket out of having to do a site visit should you screw something up remotely. Next we have some configurations on interfaces. So we'll just touch on this quickly here. We have 3 interfaces defined here. These match up to these 3 here. And we have this 4th guy down here. You'll notice that these ones are set up as trunk interfaces to enable VLAN tagging, whereas this is an access interface that allows only a single VLAN without tagging to be used. So VLAN 500 bridges across all these devices and is extended out to these different routers. In this case, an untagged link here that only supports that, and in these cases, a tagged link that can support that VLAN and any others that you want to define. So a quick example of how to add VLANs to interfaces. If we go into interface dig 101, we can do such things as switchport trunk allowed VLAN, and we can do, let's add VLAN 600. What could have possibly gone wrong here? We added VLAN 600, right? But by what we did here, we actually removed VLAN 500. If this is a production network, you could have caused a major impact to your service by doing that. Now, there are other commands that we want to investigate here, subcommands after VLAN, that we can see if we add a question mark there, such as add and remove. These are the ones you want to be using to add a VLAN. So we have 600 there right now. If we do add 500, and we look at the configuration again for this interface, we will see 500 and 600 are now present. We can also add like a whole bunch of different VLANs at once. 100, 101, 102, and these will all get tossed in there to the configuration. And you can see it will summarize that for you. It'll throw in a little hyphen if it sees that there's a contiguous block of VLANs. And likewise, we can remove that contiguous block by doing VLAN remove 100-102. And away it goes. We can then restore this back to our original configuration by removing VLAN 600. And now we're back to only VLAN 500 present on that trunk link. So that's sort of how you will manage your VLAN configurations on your trunks. That's the best way to do it, using add and remove. That way you don't have the horrible situation of, let's say there's like, 50 VLANs defined here, and you did what I just did at the start there, and you add VLAN 600, and in the process take away all the other 50, you won't have your boss coming and reaming you out about causing a major disruption in your core network or your edge network or wherever it is that you've made that change. So be very aware of that and make sure you adhere to that advice. Let's continue where we left off. So there's a whole bunch of interfaces here. They're all blank. Then we have some here that are defined. These are just the access interfaces that connect to the other switches here. And then there's a trunk interface here that's actually linking into the rest of my network and allowing me to log into these things via IP from my normal desktop here. We of course have a layer 3 VLAN interface defined here. This is what's letting me log into this guy by SSH right now. If I didn't have that present, I wouldn't be able to log in here. Now, that's not the case over here, whereas if we do that, we can see instead we've defined this fast Ethernet 1. This is like a dedicated Ethernet management interface for layer 3 access to this device. Basically, we're allowing, where it's been defined by default as to be part of the management VRF, so it's separate from any other IP, I guess, global, it's separate from the global routing table on this device if you have routing turned on. This is like a layer 3 switch, basically. It can support certain routing protocols. And there's an IP address defined, of course, and then there's other commands in place that we'll see on this device, and that sort of allows management to take place via that VRF. So back to this one though, we have turned off the HTTP server, HTTP and HTTPS server on this device. You should always do this on your Cisco devices, especially ones that may have like older versions of Cisco's iOS, because it's been found quite a few times now that there's been vulnerabilities in the web servers that come with the switches and routers of Cisco systems. So you should avoid those pitfalls by just turning it off. Use SSH to manage your devices, always. Don't use Telnet. It's bad. It's not encrypted. So, next we have an access list. Access list 50 is permitting the 192.168.1 and 2/24 networks. Basically, this is restricting access for SNMP to limit what devices on my network can talk to SNMP, as well as what devices can talk to the line interfaces, the actual SSH as logins, basically, on these systems. So we've defined that here, access class 50 in VRF also is present, although it's not required on this device. It will be required over here, where we're part of a management VRF. So to make my life easy, I just included it over here as well, so it's a standard configuration option basically for my little lab network. Now, you can also define like local authentication on your console. Right now, if I plugged in a console cable to this device and just hit enter and EN, I'd have full access. So we'll see that sort of over here, basically. These are the routers that are set up as well, and this is just a quick example of the behavior you'd see if that was the case. I'd have immediately a prompt with no password requirement, type EN, I have full control now of that device. So that's what happens when you have nothing defined here. If you define login local here, though, you're going to get a prompt asking you to log in. And then if you logged in with a user that did not have privilege level of 15, as we can see up here, then you would have to then provide an enable password, which is not configured here anyways, and nor is it on the other devices that we just looked at over here. And that would let you have full configuration privilege 15 mode access to this device. That's basically the end of the configuration. So a couple little other ones to note here. So if you're configuring it for the first time and you are enabling SSH, you will have to actually generate a cryptographic key. That's done by this command sequence usually. Crypto key generate RSA modulus, and then usually the full amount you can do, 4096, and then enter. And that will create a new SSH host key for this device. Now if I do this right now, it will overwrite the existing host key, and that'll cause me trouble, so I'm not going to do it. It also takes a bit of time sometimes to run, so be prepared to wait for that command to complete. It'll give you output and tell you it's doing something at least, so you know it's not sitting there and twiddling its thumbs. So yeah, that's one that you want to make sure you do. Another one you might want to do in some cases is to disable CDP, which can be useful because you can use CDP to observe what other devices are in your network. For instance, I can do show CDP neighbor, and I can see the switches basically that I'm linked to, and also the router that I'm linked to. If I however go in here and I do a no CDP run and show CDP neighbor, that's all gone. Now the reasons to do this are twofold. Sometimes there can be like compatibility problems with CDP. You can have issues like which can cause like a like iOS crash, or you can have a security bug, or people can use it against you. They can use it to sort of observe what's in your network. If they have a scanner that scans for CDP, which exists, they can basically say, hey, what other devices can we find here? And they can see what they're linked to and get more information about your local network. They may, that they may not need or shouldn't have access to. So that's something to do. So back to our VLAN stuff. Let's do a show span VLAN 500 here. We can see this guy is currently the root bridge. So that means that he is the master basically for the spanning tree for this VLAN. If I log back in over here, I timed out. That's something else I should look at quickly here. Let's just go through this guy's configuration very fast. So you'll see things are more or less the same. There's a couple little adjustments here, namely AAA. This is what's enabling our TACACs to function. We're enabling authentication, authorization, and also accounting to be done on our users that log into this device. So whenever you run a command on this, that's logged back to the TACAC server. So if someone changes something that they shouldn't have changed, you can see who did that and when it was done, and you can go and have a talk with them and say, you probably shouldn't be running that. Or if you're doing that, like, why are you doing it? And blah, 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 whatever. Now, the nice thing about the authorization elements here is you can do fun stuff, like you can have maybe like a support layer of users for your network, where these guys may have access to do like certain show commands, but they can't do things like reconfigure the router. Or maybe they can reconfigure the router or switch, but only certain things. Maybe they can't do commands like, no router BGP or no router OSPF, and take out the entire system's actual routing protocol for you, which would be bad, of course. But they can do other things, like they may be able to like add an interface or adjust an interface description, for instance. So that's the power of authorization. You can use that, and when we get to the TACACs video, I'll show you how you can set that up and how you can restrict who can do what on your switches and routers. So that's pretty cool stuff. Now this is also tied into the line section. So if we do a show run sec line, we'll see that the line configuration is a bit different here. This guy is very basic. This guy is not. You can see there's a lot of stuff referencing those different authorization, accounting, and authentication elements of AAA for TACACS purposes. So instead of login local, we're doing a login authentication against the VTY authentication group. It is, I believe, or command set. So basically, that's making sure that our actual logins or commands are associated to these different things here, more or less, and that's how that's tied in. We'll go through all that anyways in the actual TACACS video, basically, so we'll look at the specifics about that and how to set that up. And now, again with the VRF stuff, you can notice in here that's defined. It's telling it, make sure that you use that management VRF and you source it out of that management interface when you talk to the TACACS server. You didn't see that over here because it's part of this device's global routing table. It's not in the VRF. So that's a bit of a difference that you'll observe there. Just in my design, I could maybe set up a separate switch, if I had one, to act as my out-of-band switch and plug this device into that as well as these devices into it, so that it wasn't all sort of coming through this one host here. Once again, make sure you have a separate out-of-band management network to your normal production stuff, because it's going to save you. Like if you do something bad and blow away a critical link by accident, then you'll be able to come back in via out-of-band and fix it, and vice versa. If you destroy your out-of-band network somehow, you can come in via an in-band login and fix that as well. So let's just do some little quick demonstration here. This is just to show what you can do with spanning tree. So we'll log in over here on this guy as well. We've got some pings going. You can see here these are the IPs of these two routers, 192.168.150.3 and .4. And we'll just do a quick little ping flood. Ping 192.168.150.4 from the the lab R3 router. We'll repeat that a million times. And we'll do the same thing over here in the opposite direction. 192.168.150.3, repeat 100.000.0, and we'll let that go. Now we'll go back to our switches. And if we do a show spin VLAN 500 here, we're going to see that there are a few ports involved. We have port 1/2 and 1/3. This guy has the role of the root interface, and it's got a status of forwarding. This is the alternate interface, and it has a status of block, which means that it's not going to pass any traffic. That's to prevent a layer 2 loop from forming. You never ever want to turn off spanning tree in your network. If you're doing that, don't ever do that, because that's going to introduce other problems that will really bite you one day. If you have a layer 2 loop, the entire network is going to melt down, and that's how people lose jobs. So don't be doing that. So as we can see, these are the links involved: 1/2, 1/3, 1/34. 1/2 is currently active. What we're going to do is we're going to take this link away, and we're going to see this one take over. And it should do so very quickly. So we'll have a minimal disruption to our traffic over here, which we can see. So let's go over here. We're going to go into configuration mode, int gig 1/2, which is lining up here, as you can see, 1/2, 1/2, and we'll shut this port down to force traffic to flow over this way instead. So let's just do a shut. We'll immediately go over here, and we'll see a disruption has occurred, but it came back very quickly. We lost one packet in that direction and 2 packets in that direction. Now, if this was like a TCP flow, it'd be fine. TCP would say, there was some loss, I'll just retransmit those packets and, I'll get on with my life. If it was something like a voice call or something that used UDP, there'd be a minor disruption, but it wouldn't be very noticeable, and it would recover so quickly that most likely your user base isn't going to really care. So this is sort of how spanning tree can protect you from failures at layer 2. So you can design your architecture to avoid issues by by actually utilizing what would, without spanning tree, be a looped layer 2 network, but with spanning tree is a redundant layer 2 network. So make sure that you understand how that works. And again, we'll do a video on spanning tree itself, so you can see its how to implement it, how to adjust things, how to do all you need to do that's involving a spanning tree to make sure that your network that your network is solid from an actual layer 2 perspective. So the last thing we'll do here is let's do a very quick addition. Let's just see what it takes to add a new VLAN across our little network here. So we'll stop that traffic there. And I'll move myself here quickly. So we'll do a configuration change here. So if we do a show run int-gig 0/0 on these guys, we're going to see that there is a physical interface defined here. And if we do 0/0.500, we'll see that I've defined a sub-interface. Let's just add a new one here. We'll go in here, conft int-gig 0/0.600, over here as well. We'll make a new network on this, basically. We'll do encapsulation.1q 600 to define we're using VLAN tag 600 on this sub-interface. That won't happen by default. You have to define this for a sub-interface in the router. And then we'll just do a new IP address definition. We'll do 160.1. And over here, 160.2. Let's use a /24. Why not? It's fine. And that's good there. And whatever, and that as well. So that's been done. Now if I try and ping this thing, so if I do like a ping 192.168.160.1, I can ping it locally, but I won't be able to ping across because there's no linkage yet. So let's fix that. Let's put our linkage in place. So we'll start over here. Log back into this guy. Now I will go into configuration mode, and we'll define VLAN 600, name, test, doesn't really matter. You don't need to put a name in there really, but that's okay. And then we're going to go over to our interfaces. So this guy is going to be needing an actual definition on these interfaces here. Really just these two, but let's just get this done here. So we'll go into int gig 1/2, and we'll do a switch port. Trunk allowed VLAN add 600, and we'll do the same thing on 1/34 and on 1/3. So that's all now present across the board. That's good. We like that. And then we'll go up and do the same thing over here. Let's see. We have to be concerned of 102, 103, and 101. So start with 101. Switch ports, you know what we didn't do yet, we didn't make the VLAN. VLAN 600. Name test, int gig 101. Switch port trunk allowed VLAN add 600. 102, same thing, and 103, same thing. So we've built across there now. Now we'll continue our trend. Let's no shut that, we'll bring that back. That may sometimes cause a very brief disruption, but it won't be as large as when that link failed. So we can see here it already came back, but yeah, let's get this done here. VLAN 600, name test, and then we will do int gig, and this guy is going to be 11, 12, and 13. 1/1, switch port trunk, just copy it, I guess. Make our lives a little easier. Get that guy in there. 1/2 and 1/3, and that's added up. And lastly, we'll go down here to this guy and we'll add it over on this. Conf t int gig 1/2. Yeah, 1/2, 1/3, and 1/34. And again, we will do the same command. Oh, we didn't do is we didn't define it. VLAN 600, name test, int gig 12. Should already be there anyways, but there we go. int gig 1/3 and 1/34. That's now present. Now, if we go back to our little routers here and do a test, we should be able to get traffic to flow. And there we have it. So that is adding a VLAN to an existing switched network. Not that hard, really. As long as you obey those little rules and make sure you're, not creating loops by turning off span entry or anything silly like that, then you'll avoid troubles. Now, let's see if things are the same for this one. Show span VLAN 500 and VLAN 600. You see there's a bit of a difference there. So because we didn't include other options, span entry is sending traffic elsewhere. So this is how you can do fun stuff like load different links down in your network. You can have one path that's for one VLAN, a different path for a different VLAN, or sets of VLANs. And you might notice other types of changes. So VLAN 500 here is the root bridge. Is it still the root bridge for 600? No, something else is. So again, this is where you need to pay attention to this stuff. And we'll go through this in the next video and look at how you can adjust span entry stuff. But I think for now, this is enough to start you out with to make sure you know how to, change things in the layer 2 level and how to manage VLANs and sort of augment your network as you need to ensure you have different VLANs. Again, just like some security notes here, like if you're setting up a new network, and go through and figure out what actually needs to talk to what directly, like from like a host-to-host basis. And if you really need to have host-to-host communications, then those devices can go in the same VLAN. If not, if you have the budget to do so, and you have like a decent firewall or router that can support filtering traffic based on IP and port and protocol and such, then separate things. Have like one VLAN for your cameras, one for your your sales staff, one for your HR, your support staff, VLANs for maybe like guest ports if you have that. Probably shouldn't. Maybe if you have like a like wireless service, like you have like a guest wireless network, put that on its own VLAN. Separate things, because by doing so, you prevent direct device-to-device communications from taking place, which is inherently more secure, because now everything has to flow through a central point to get to other devices that are of a different class or a different group of users. This lets you do things like inat policies, so you can say restrict communications between machines, so that traffic that doesn't actually need to flow between like your sales and your HR computers can't. And that's going to help you if there's a compromise situation on your network. If like a certain host is compromised in the sales network, it can't reach out and touch things in the HR network or in the support network. And you can use this type of segregation in many different ways. So you can ensure that you have a secure and robust operation, and that if there is like a failure of some kind, it's isolated. It's kept in its own little compartment. So definitely make sure that you understand and use VLANs in your networks. That's it for now. If you enjoyed this video, please like, please subscribe, just so you can see more, and hit that little bell so you actually are notified when there's more videos. I'm going to try and get back into my normal posting routine soon. I've been busy. And if you have any feedback at all, or any questions, just go down below and put that in the actual comment section, and I'll get back to you as soon as I can. Anyways, I will see you guys next time. Take care.